Hello everyone, welcome back to this new technology moment, and today with this very interesting video adding to our tested devices this fantastic access point from EnGenius, devices that we had been wanting to test for quite some time now, and in this opportunity the ECW520. This is an EnGenius cloud managed tri-band Wi-Fi 7 access point with a 2x2x2 antenna configuration. It provides pretty interesting speeds. These are the theoretical speeds that you can see on screen. You can get each one of them in each one of the bands. Remember, those are top link theoretical speeds. More of that in a moment. It features 2.5 gigabit Ethernet, as you can see right here, in the high user convergence capabilities, letting you implement these devices in demanding scenarios where a great deal of users are going to converge into small areas and need, of course, very fast internet access and networking access speeds, either directly or through a hotspot. This is what you should expect from this video so you can get an idea of what we're going to share with you. First, of course, what you get in the box and main considerations when implementing this particular model that we tested, the ECW520. Second, we're going to be showing you how simple its installation and initial configuration process is. Third, we're going to be showing you how far you can go deploying Wi-Fi 7 solutions with these EnGenius devices, its main advantages and features. Fourth, a review about its performance and how it could be improved over tweaking its values in the cloud dashboard. Fifth, our conclusions, our recommendations, and of course, a very short advice for implementing your whole new Wi-Fi 7 solution. So let's get to the point. What you get in the box for this, the ECW520, is the access point itself and a couple of supports for wall, ceiling, or rail mounting. That's it, and basically that's all you're gonna need. Well, sort of. Even though you can power it with a 12-volt power adapter or through a PoE switch connected to its LAN port, ideally a 2.5 gigabit Ethernet power over Ethernet capable switch is needed. In case that it is 2.5 gigabit Ethernet but not PoE capable, you can get an ejector like this one, the EPA 5006 GAT, or similar model that can take you up to 2.5 gigabit per second, which is very important. And about all this, and right to our topic, there are just a few considerations when implementing fast Wi-Fi 7 solutions, as Wi-Fi 7 supports much higher transfer rates and great user convergence or user density. And in a nutshell, these are cabling and switches, of course, PoE or power injector, and the use of the 6 GHz band and picking which channel to use. And as I said, in a nutshell, because as you may know, and as we have seen in past videos related to Wi-Fi 7, those have become the most important aspects. Let me show you why. Many Wi-Fi 7 access points feature a 2.5 gigabit Ethernet connector or 10 gigabit Ethernet connection. This means that there is no point using one of these great access points in the switch, cabling, or gateway if it supports only gigabit Ethernet. Otherwise, those will act as a bottleneck for your concurrent clients. Okay, so 2.5 gigabit Ethernet switch, and as for cabling, certified Cat5e cable, which will run the 300 feet at 2.5 gigabit Ethernet with no problem, as we've seen in other videos too. This takes us to a second consideration. If you're gonna connect to a power over Ethernet switch, that switch should at least be 2.5 gigabit Ethernet, at least for this particular model of access point. There are similar models from the brand which run at 10 gigabit per second. Again, otherwise, that connection may be your bottleneck. If you have a switch capable of delivering 2.5 gigabit Ethernet, 5 or 10 gigabit Ethernet, but it is not PoE capable, like this one, you can consider buying an 802.3AT power injector that explicitly states 2.5 gigabit per second or faster speeds. However, most gigabit Ethernet injectors will deliver 2.5 gigabit Ethernet connections, like in our case. It is not very common, at least for now, as they are much more expensive to get a 2.5 gigabit Ethernet switch capable of delivering class 4 PoE. You may even end up using just a couple or a few 2.5 gigabit Ethernet power over Ethernet ports. Our final consideration, the use of the 6 GHz band, is still not allowed everywhere in the world, and picking the right channel or combination of them for a higher channel bandwidth is something that must not be addressed lightly, as you may misconfigure a simple setting and could end up blaming your access point for poor performance. That is one of the main reasons why some Wi-Fi 7 access points are not available for international shipping, and the same thing happened with Wi-Fi 6E access points. The greater the bandwidth, the better transfer rates of course you'll get, but the less compatibility that you'll achieve, especially with older Wi-Fi clients. Let's go to our initial configuration. As usual with many cloud-based switches, access points, or in general cloud-managed networking gear, initial configuration may depend on that first boot, being connected to an active network. This means a network with internet access. No alternatives here. Scan the QR code on the box and take a look at the product page where you will find all the information that you need to make a robust Wi-Fi 7 deployment. You'll see technical specs, what to expect from each radio of your access point, guides, resources, access to the download center, everything that you need not only to set it up, but what you get in the box, operating conditions, and much more. As we said, this is the ECW520. Right after you download the EnGenius Cloud2Go mobile app, create an account. This is in case that you don't have one, and select Add your first EnGenius Cloud2Go device. In this case, we opted to scan its QR code on the back. Then we select Register, name the device or devices, and it's added to the default site. You can always change that name later, either the access point or the site. In no time, your device will be ready. Our advice, of course, is to just let it sit for a while without disconnecting it, as it may have updates to be applied. In the meantime, for example, you can create your first SSIDs. Remember that you can create up to 8 SSIDs per radio. This means, for those of you who are new to this, that you will be able to create 8 different network names for each one of the radios. If you had, for example, different uses for each one of the bands, you can actually have 24 different networking names. Okay, so what are the advantages of implementing an EnGenius cloud-based Wi-Fi network with these access points? Out of the many cloud-based solutions that we have tested and used in the past, maybe the EnGenius control panel is the most complete and configurable that we have seen. There are endless menus and possibilities that at first may seem not so organized, or more than that, may be a little overwhelming for inexperienced users. We repeated the SSID creation process here, and as always, much easier to do it on your desktop computer than in any other mobile device, of course. Many menus that will let you configure anything that you want in your access points and will let you have quick access to the relevant information that you need. Some options, however, are only for subscribed Pro users, and as that is something that we do not encourage so much, we are not going to discuss that deeply. You'll be able to configure one access point individually or deploy changes globally to your Wi-Fi infrastructure of many of these access points to thousands of users. The same thing for your radios, individually here from the access point configuration or the global access. How far can we go with this type of access points? This question may be asked by many. Well, that will not depend on the 500 limit client for each one of the devices that can connect to it, which in essence is quite good, but how your hardware may be able to handle huge amounts of concurrent devices. This means your gateways, your switch capabilities, and of course these access points that will let you deploy Wi-Fi networks for several thousand clients just by having a few units of these. Through the interface, some things are not easy to deduct. Quick example, changes cannot be made right here from the screen, from the preview panel of each access point, even if it seems like you can do it. But changes have to be made from the detailed access of each access point. Anyway, you'll find out the way, but takes time to understand these small things. The dashboard, however, is very comprehensive in general for tech professionals, giving you a very complete overview of your network warnings, client distribution, traffic, even without the use of an EnGenius gateway with DPI, which is very good. All this, by the way, can be done from the app, which will let you manage your network or many networks in case that you are an IT professional handling several businesses. SNMP, bandwidth limit, schedules, roaming options, which we have analyzed in the past and seen how important they are. MLO or multi-link operation, which we tested and works very well on these devices, and much more. Hotspots, by the way, or captive portals, are as easy to deploy as it gets with these access points, as you will not need any physical controller in your network, nor to be present at the premises to deploy, for example, a voucher-based hotspot, which worked very well in our tests. A radius server authentication, very used nowadays, also intuitive to deploy, and even EnGenius Google Azure authentication is available. By the way, we may have to go a little deeper into insights for that, as these are pro options. We really like the level of control that you can get out of the hotspot option of these devices, as well as the level 2 isolation for any network. On the other hand, we could not create a mesh network as we only got one access point. We hope to get another one of these in the future to test how good it works. But you'll be able to achieve a great level of configuration implementing mesh networking using these APs, having deeper controls of the protocols involved, as we've seen in previous Wi-Fi 7 videos. Okay, now fourth, what about their performance? A question that may be asked by many. There are many ways that we could describe this particular model from EnGenius in terms of performance, even though for single client testing we did not achieve the level of transfer speeds that we have seen in Wi-Fi 7 devices in the past. We could better describe our network test as reliable, scalable, and high user density deployment. Let me explain. We did get very good Wi-Fi speeds, very decent performance for file transfers, but you may say, hey Alan, that is nothing out of the ordinary, and some may even point out those are Wi-Fi 6E speeds. In terms of single client's dedicated speeds, you may not get such transfer effective speeds. These are access points that are stated to be for 500 clients, and even though the manufacturer does not specify the client distribution depending of course on the radius it features, it is very likely that the higher the frequency, the higher the number of concurrent clients. We may add that information later in the comments. Let's keep in mind that this is the radius distribution of this access point. It is a 2x2x2 antenna configuration, and as more and more devices continue to migrate from the 2.4 and 5 GHz band to the 6 GHz band spectrum, that will be much better for the number of active clients connected to the access point. But what all this means, in plain and simple words, is that these access points are not oriented for a very high-speed Wi-Fi clients drawing 2.5 gigabit per second each, but what this means is that there is going to be enough Wi-Fi networking power for many concurrent devices at still very good gigabit Ethernet speeds. Here you can see that one client is connecting to a server in my network at about 1 gigabit per second and still has enough power to serve other gigabit per second clients, and this is not even involving the 2.4 gigahertz band. Besides that, being able not only to transmit and share information with wired servers, but also between them, something very relevant nowadays. By the way, this, in our tests, performed very well. All this while the rest of the clients of your network keep very good networking connectivity alive and at good transfer rates. Even more important, we tested between a Wi-Fi 6 and a Wi-Fi 7 client, these between two Wi-Fi 7 clients, and this a Wi-Fi 5 to a Wi-Fi 6 client. Very interesting, very good Wi-Fi speeds between them. In the previous chapter, we mentioned the level of configuration that you can achieve with these access points. And besides the speed control, availability, virtual networks, hotspots, MLO, reporting, diagnostics, and much more, performance and user convergence may be one of its strengths. You just have to be quite careful when tweaking channels, channel width, and basically any configuration, as you might end up configuring contradictory settings or not optimized for your particular model of access point where single client connection is not its focus but high user density. Our conclusions are plain and simple. We found an access point that is solid, reliable, and being able to handle a great deal of concurrent connections. Of course, always consider that the more clients that you connect and actively demand networking access, the lower the effective network speed that you're gonna get. That sounds obvious, but in Wi-Fi, that could not be more relevant. It doesn't matter the access point that you use, the channel, nor the transmission power. The important aspect is how the access point keeps those connections alive, and at that, we found this access point to be very good at. In terms of range, the answer that we hate to give, but we just cannot change it. It depends on many aspects. How crowded your surrounding spectrum is, which means how many Wi-Fi networks surround you, and this is critical in densely populated areas. Construction materials of your building is not the same wood and drywalls against brick and concrete for Wi-Fi blocking. Orientation of the access point, vertical or horizontal, and not less important, the transmission power of the connected devices, not the access point, the connected clients. We've said before that we're always gonna find things to improve, and we noticed a few. A small delay for reporting new clients, and this is typical in cloud-based systems. But in general, this is an access point that connects Wi-Fi 4, 5, and 6, as well as it connects Wi-Fi 7 clients, which, as we have noticed, not all brands have managed to find a good balance. The same with older standards that, by the way, you can just deactivate. The last thing to improve, sometimes you do not know if the changes that you made are being applied or not, as there is not something that actively tells you what's going on, and as changes sometimes take a minute or so to be applied, you might end up thinking that your changes are not taking effect. We do not encourage the use of monthly subscriptions, but for the level of benefit that you can get from this, it might be worth a try, especially if you need more statistics, more options for your hotspot, and templates for very robust deployments. Okay guys, I hope this video was as informative and condensed as intended, as we value your time spent watching our videos, your great support for us to be able to continue creating all this content for you. Hit the like button and subscribe to our channel. Thanks for watching and see you next time.